Hello AP Calculus students. Time for another tutorial video. We're on topic number 2, which covers domains, and we're going to be taking a look at example number 9. And before we get started, let's just give a brief overview of what a domain is. As you can see here, a domain basically just defines the range of the x values that gives a valid y, or an answer for the function, when you plug in that x. So for example, if you have a square root, anything inside of that radical, the square root, has to be a positive value. So you would be looking for the values inside of that square root that return a negative amount. Therefore, that would not be in the domain. Second example involves a rational function, which is just a fraction, and we're looking at the domain specifically for the denominator. The bottom, you remember, cannot equal 0, so to find the domain for the second example, you would just set that x minus 7 equal to 0, and you would determine that the domain cannot equal 7. So with that in mind, let's get started. So here we have two radicals, one in the numerator. It's a cubic root, which, if you recall, odd powers inside of the radical, they can contain negative numbers, so we're not going to be concerned with that numerator so much, but we are going to take a look at the denominator. So when that denominator, which is also inside of the square root, when that equals 0, or when that value returns a negative, then this whole domain would exclude that. Alright? So let's go ahead and take a look at this. First thing we notice is that this trinomial x squared minus x minus 30 can be factored. So if we do that, it should look something like this. X plus 5 and x minus 6. Once again, we're not going to do anything with the top, so I'll just rewrite it. And looking at the bottom, if we set these two equal to 0, okay, so when x minus 6 equals 0, which occurs, of course, when x equals 6, that causes this entire denominator to go to 0, which is going to restrict it from the domain. The second situation is when x plus 5 equals 0, which would send x equal to a negative 5. When this occurs, the whole thing would equal to 0. Okay, the second case that we need to consider when looking at the domain for this function is what causes the inside of this radical to be less than 0 or negative. So if you think about this for a second, the graph of this would roughly look something like this, with the roots being at a negative 5 and x equals 6 right here. So anytime the graph dips below the x-axis in this area here, it would cause this domain to be, or the denominator to be a negative, which we can't allow because it's a square root. So basically, what's off limits is anything between a negative 5 and a 6. Another way to think of this is, when is this function going to be valid? Well, that's anything that is less than a negative 5 over here, and when it's greater than a 6. So the preferred method on this would be to write the domain as follows. X can be less than a negative 5, and unioned with the set when x is greater than a positive 6. Okay, so this satisfies the situation. Notice that we didn't include negative 5, or we didn't include 6, because those in fact would make this denominator equal to 0. Alright, well, I hope this helps out with the rest of this section on domains. Once again, drop me an email if you have any questions about this example or any other problems that you're having in this section. and we'll talk to you soon.